Hey, hello everyone. So today we are going to solve basically the LeetCode's daily problem. So let's take a look at what it says. It basically complement of based in integer, very like straightforward question. The complement of an integer is the integer you get when you flip all the zero to ones and all the ones to zero in a binary representation. Okay. Uh, so basically what it says that in the binary representation of the number, you have to just flip the bits. For example, the integer 5, the binary representation is 101, and if you um, take its complement, it's 010, which is integer 2, and given an integer n returns it okay. So basically, what it asks that you are given a number n, you have to do what you have to flip the bits, which are basically significant, so and then return the result. So for 7, like for 7, uh, 7 the representation of binary of 7 in binary is 111. So whenever we will flip the bits, it will become 000. So result will be 0. And for 10, the what will be the representation? 10 will be 1010. So if we flip the bit 0101, it will become 5. So that's the question. So what we can do? So I'm going to solve this in C++. So first of all, there is a bit operator. So basically to flip the bits. Uh, the tilde symbol, that tilde symbol is bitwise not, which basically simply flip all the bits in a number, including the sign bit. So if we just only return the, so in first loop, it seems that if we only return the tilde n, it should work. But if we run this, it won't work. Why it won't work? Mm, like you will get, you can see that we are getting some negative answers. So why so? Basically, all integer numbers are basically represented in 32-bit binary format, right? So if n is 5, so if n is 5, what will be its binary format? Basically simply 101, right? But in computer there are 32 bits, so basically there are more bits which are 0. Basically here. Okay, so there are total 32 bits. And if we simply use negative bitwise not operator, right? So what does bitwise not do? Bitwise not simply flip all the bits. So basically flip these zeros to 1 and 1, 1, 1, 0, 1, 0, right? So bitwise not do these things, and this as this is a sign bit, so the number become negative and so and so. But what we are asked to do, we are asked to do that as the number is only significant up to this bit, we have to flip all the bits in this range basically and return the result. We don't need to flip these bits. So what can we do? So one simple approach can be that we do negate n and get this result and just take this portion. And how to take this portion? If we can anyhow create a mask of like this and all the rest are zeros. This is basically suppose we are building a mask, right? And if we AND both these things, sorry, basically if we AND both negate end and this mask, what we'll get? We'll get our result, right? Basically we will get all the zeros and here 010. So first approach will be that we have to get a mask where all the bit up to the MSB will be 1 and the other rest of the bits are 0. So how to get this? If we anyhow can count like how many bits are useful, like how many bits needed to represent this number, then we can easily make this mask, right? So here, how many bits are needed to represent 5? Basically 1, 2, 3. So 3 bits are needed to represent 5. So mask will be basically 2 to the power 3 minus 1. So we know that the mask of length n, where all the bit set are to the power n minus 1, right? So simply, first of all, we need to count that how many uh, bit, at least how many bit we needed to represent 5. Then we are going to create the mask by this to the power n minus 1, and then we are simply going to and both the mask and the bitwise not of n, then return the result. Okay, but let's take a look in the range of the n. So 10 to the power 9 upper range is good, but lower range is 0. So for 0, it won't work. Why? Because for 0, all the bits are 0. So what will this, like how many, at least how many bit we needed to represent 0? It should be 0, na? Basically, we don't need any bit to represent 0. So then if we uh, get this into the formula, that 2 to the power 0 minus 1, so our mask will become 0 and the result will be 0. But here, according to the problem, the 0 need 1 bit, and if we negate them, flip them, the answer will be 1. So for 0, the answer is 1. So we have to handle it manually, right? So what we'll do, basically, if n equal to 0, we are simply going to return 1. Otherwise, we need to find, first of all, how many bit, at least how many bit we need to represent the number. So basically bit. So there, either you can like calculate it manually, or there is a function, um, standard function to get this result, that is stand bit width. Here is the reference. So what does bit width do? If x is non-zero, calculate the number of bits needed to store the value of x. Okay, so which is basically 1 plus floor of log x base 2. That's very standard thing. So we are going to use this function bit width. So we are using bit width. It takes unsigned data types, so unsigned sort, unsigned int. So we are going to typecast these to unsigned. Now we got the base, so bit. So now we are going to make the mask. So constant int mask. We mask is simply the formula is 2 to the power bit minus 1. So we are going to use the right shift operator to get the power minus 1, and we are just simply going to return bitwise not in and mask. So this should work. Let's check this setting. Yeah, let's submit this. So it worked, right? It's bit 100. This is not that much. So now we got the idea that how to solve this question. Now uh, we are going to solve it manually. Like we are going to a different approach, that in n we are going to traverse bit by bit up to the most significant bit, and if we face any one, we are going to set 0 in the answer, and if we find it 0, we are going to set 1 in the answer. So how to do that? Basically, first of all, for that, let's say n is 5, so that is 101. First of all, we will see that the least significant bit, if it is 1 or not. So first of all, our answer is 0, which is 0, 0, 0, and n, this is n, and our answer is 0, right? So what we are going to do, first of all, we look into this MSB and see that this is 1. So in the answer, this should be 0. So we do nothing. Okay. Uh, this is bit position for that bit. Now we are going to go here and see that this is 0. So the in the answer this should be 1. So we will go here and make this 1. Make this bit 1. Now we will go here as this is 1. This should be 0. So we won't do anything. So this will be our manual approach that we will go bit by bit and check if the bit is 0, we are going to set it to 1. So for that, what we are going to do basically, mm, int answer is 0 basically first of all, and int bit is 0 is 1. So basically what we are doing, bit 1 means that we are in that position, or let's say it mask. Okay, so basically what does mask do? Mask initially when we are in this position, the mask is 1. Okay, so basically this means that if we OR both the thing, the this position will change, right? In the next traversal, when we will traverse here, the mask will become 0 1 0, right? So basically in the mask we are setting that bit to 1, which we are traversing here, and then we will do OR to manipulate this. That is the basic approach. So mask is initially 1. Now while in basically greater than 0, what we are going to do, first of all, we need to check the LSB of the n, that if it is set or not set. If it is not set, that is n and 1, basically check if the least significant bit is set or not, and we are taking basically not of that, so that we can find if it is 0. And if it is 0, what we are going to do, we are going to simply answer or equal to basically mask. We are going to mask or that with the mask. But that is in one iteration. After that, we are going to change the mask position by shifting it in the left direction 1 and going to shift in by right direction 1, and we are going to simply return the answer, right? This is the manual approach. This should work. What we have done, uh, while n is not 0, means we are going to traverse up all the bit up to the MSB and checking if the least significant bit is 0. If it is 0, then what we are going to do, we are basically manipulating, basically setting the that particular bit to 1 in the answer uh, by OR it with the mask. The mask is basically a special number in which only bit is 1, which we are traversing in n. And after that, we are just changing the mask and it should work. Let's check it. It should pass. And yeah, it got passed. So that's all for today. Thank you. Thank you, everyone.